and the small molecules will pass through them. Some are always closed, only when ATP will work on them, will open the channel. Receptors, as I have explained already, you see the signal molecules like medicines or hormones will bind and then will work. Some integral proteins act as or work as enzymes and change the molecules from one form to another. So this integral protein is changing this chemical to another chemical, and this one is also acting as another type of enzyme which is changing this one to this one. So just a simple diagram. Okay, so those are the functions of the integral proteins. Now we'll talk about the functions of peripheral proteins. Peripheral proteins have two important functions. How many?
Two.
Okay, so we'll talk about that. Peripheral proteins form cellular junctions or joinings and act as help to recognize other cells. Help to recognize other cells. That is called cell-to-cell recognition. Okay, so how the peripheral proteins form the cellular junctions. So this is one cell, this is the cell membrane, you have the peripheral proteins, the outer side of the cell, these are the peripheral proteins, okay, and this is another cell, peripheral proteins. Make sense? So this cell membrane has peripheral proteins, this cell membrane also has what? Peripheral proteins. Make sense? And these peripheral proteins, you see these peripheral proteins of this cell and these peripheral proteins of this cell, they are getting what? Attached to each other. Make sense? And holding the cells, what? Or cell membranes tightly. Okay? Holding them together. So the cells will not easily get separated. Make sense? In the tissue, the cells will stay together. Clear? Okay. So that is the cellular junctions. Okay? That are the cellular junctions. Hold the cells in the tissue together. There are three types of cellular junctions: tight junctions, gap junctions, and another type is called desmosomes. So just know that. How many different types of junctions? Three: tight, gap, and desmosomes. Okay. Tight junctions are like heavily sealed junctions. So almost no chemicals are allowed to pass through tight junctions. That's why they are called tight. Okay. Gap junctions, if you see the structure of a gap junction, you'll see tiny hole is present. So the molecules can easily pass through the gap junctions. Make sense? Gap junctions have channels or pores. So the molecules can pass through the gap junction. That's why they are called gap. Desmosomes are very strong junctions to hold the cell membranes strongly attached, very strongly. You know, have you seen the zipper you use in clothes, right? Desmosomes are like that. So they do what? You see, this is one cell, this is another cell. From the cell membrane, protein structures come out like this and they get attached to each other like this. This is from one cell membrane, this is from another cell membrane, and hold them very strongly like this. Make sense? So the cell membranes will not get separated. Okay? So these protein structures are called cadherins or linker glycoproteins. Cadherins, also called linker glycoprotein. Same thing, okay? Cadherin or linker glycoprotein. They hold the cell membranes very strongly, very tightly. So, like zipper of your clothes.
So those are desmosomes?
Desmosomes, yeah. So desmosomes have linker glycoproteins or cadherins, okay? They are like this. In your skin and heart muscle, you have plenty of desmosomes. Have you seen when skin gets dry, you can peel the skin, right? That means many cells are coming up together, attached to each other. It's difficult to separate them, right? So, sometimes you'll see snakes, they change their skin, right? So whole skin comes up, right? Those cells are strongly held together by desmosomes. Heart muscle, you know, when heart contracts, all muscle fibers, cardiac muscle fibers, must work together, right? So they are attached to each other very strongly. All of them must contract at the same time. It's like, you know, if many of you hold each other like this, right, side by side, nobody can, you know, function individually. When you move, everyone has to move, right? When everyone moves, that gives strong power. Make sense? So it's like that. The cells are attached to each other by desmosomes. So the function, they can perform the function together. So those are three types of junctions in the cell membranes given by peripheral proteins, remember. Now, cell-to-cell recognition, recognizing the other cells, very important function. If you need skin grafting, your skin got burned, you need skin from another part of the body, okay? Now, if you get the skin from another person, the chance of rejection is high. You know that, right? If you get any organ or part of any organ from another body, another person, your body rejects, right? In many cases. But if you get from your own body, it will accept. Make sense? That means what? Very simple. The cells of your body can recognize the other cells. Make sense? So if I give tissue from another person or cells from another person, tissue means collection of cells, the peripheral proteins, some peripheral proteins can recognize the next cell or adjacent cells. Okay? Can do what? Recognize. Okay, so peripheral proteins can do that if it is from that person's own body or from another person's body. That's a big deal, right? You know that. Transplantation of tissue or organ, right? Rejection, that's a big problem. So the peripheral proteins can do that, can recognize the other cells, adjacent cells. That is the cell-to-cell recognition. So here you just now understood three types of cellular junctions. Here they have just shown the structures of those three types of cellular junctions. These are tight junctions. This is one cell, this is another cell, this is another cell. So these are tight junctions. These are desmosomes. You see the linker glycoproteins or cadherins come out and get attached very strongly like this. Okay? So desmosomes. And gap junctions. These are gap junctions. Makes sense? You have pores or channels to the gap junctions. This is the structure of a desmosome. So these are linker glycoproteins or cadherins that I showed you here. Okay? This is one cell membrane, this is next cell membrane. So cadherin come out and get attached to each other like zipper. And inside the cell membrane you have disc-like structures, those are called plaques. So what happens, see, let me show here. This is inside the cell membrane, so you have plaque. From the plaque, the cadherins come out like this. So this is the plaque, and these are the cadherins. This side you have also plaque and cadherins. Okay, so that is the desmosome. Gap junction has channels. Okay. So the fluid can move, or chemicals can move from one cell to another easily. The cells can talk to each other very fast because the doors are open. Make sense? You have several rooms side by side. If the doors are open between them, you can easily communicate. Make sense? So these cells can easily communicate through the gap junctions because of the gap junctions. Transport across the cell membrane. Cell membrane is what type of membrane? Anybody remember? The very beginning I said semi or semi permeable, right? Selectively permeable. So it allows some chemicals but not everything. Which is good or bad? What do you think? Should your cell allow everything, toxic chemicals enter into it? No, should not, right? That will kill the cell. So, selectively permeable. And through the cell membrane, two ways the chemicals pass. Active and, both ways. Two methods or processes. One is called active transport. And another is called what? Passive transport. Which one requires energy? Active, right? Passive doesn't. Like, you are sitting on a boat, okay? And the current is against you. So if you want to cross the lake or river, you need to start the engine, right? That gives energy. So sometimes you need energy to move, right? Now, if the current is in your favor, then you may not need the engine, right? You just sit on the boat will go by itself, okay, without the starting the engine. Make sense? So that is passive. Okay, you are not spending energy on ATP. So active transport requires ATP. Passive transport does not require ATP.
Mostly, is that true? Mostly active is from outside to inside and passive from inside to outside?
This is the protein, and ATP, in most of the cases what happens is, see, in active transport, the protein works as a pump. So this is outside of the cell, like sodium is getting in, okay? At the same time, the pump is pushing the potassium out, another chemical out. So it's like acting as a pump, but most of the cases both ways, okay? Taking one in, pushing another out, okay? So passive doesn't need ATP or energy. So ATP is produced in living cell, right? By what? Mitochondria, remember? Mitochondria. So that's why we say active transport can only occur in the living cell membrane because it requires ATP, and we need it. We know that to produce ATP we need metabolism, mitochondria, right? So that can only happen in living body, metabolism. Okay, so active transport only occurs in living membrane. Passive transport can occur in living as well as non-living membrane. So those are the differences. Now, there are two types of passive. One is called diffusion, another is called osmosis. These two are important passive transports. There are a couple others, just know these two, diffusion and osmosis. I will explain these two. Okay? So this is a cell membrane. This side of the membrane you have glucose solution. So you have glucose molecules, these are solutes, and water. Make sense? Glucose solution in high concentration. That means you have more glucose in this side. Make sense? High concentration. In this side, you also have glucose solution, low concentration. That means few glucose molecules, low. Separated by semi-permeable membrane. Okay? Now, the goal here of transport through the cell membrane or semi-permeable membrane is bringing equilibrium. Okay? That means same concentration in both sides. Okay? That is the goal. Just remember, that is the goal. Bringing equilibrium or same concentration in both sides. Now you tell me, very simple question. In this side you have less glucose, right? This side you have more glucose. So which way glucose molecules should move? This side to this side, because this side has less. In this side you have more what? Water. So water should move from this side to this side. Make sense? So water will move from this to this. From low to high, water will move, right? From high concentration to low concentration, glucose or solute will move. To bring what? Equilibrium. Same concentration in both sides. Very simple. This side you have more glucose, this side you have more water, less glucose. The glucose should move from this side to this side, water should move from this side to this side. Make sense? So this is called diffusion and this is called osmosis. In osmosis, water or solvent moves from what? Low to high. In diffusion, solute like glucose will move from high to low. Okay? So those are two important passive processes. Okay? The goal is bringing equilibrium. Okay, the last thing. If you take some, solution in a beaker and put a cell, for example, a red blood cell. This is a red blood cell. Okay? Now, the concentration here is high. That means hypertonic. Hypertonic. Compared to the cytoplasm of red blood cell, you have low. Concentration is low here inside. That means this solution is what? Hypertonic. Compared to the cell. Which two we are comparing, that is the important thing here. Okay? Cytoplasm is low concentration, solution is high concentration. That's why this solution is hypertonic. Okay? Now you tell me, water will move which way? Water will always move from low to high. Osmosis, right? Remember that? To bring equilibrium. So in this case, water will move from low to high. That means from inside the cell to the solution, to the outside. Is it clear, everybody? Water will move from low to high. So in this case, low is where? Inside the cell. So water will get out, right? So the size of the cell will get bigger or smaller? Smaller. Makes sense? Water is leaving. So gradually shrink. So in hypertonic solution, the cell will shrink. Is it clear? Okay. Now I have changed the concentration of solution. Now this concentration is very low, so inside is high. This one is same, remains same, but now here is low because I have changed the solution. So this is hypotonic. Solution is now, concentration is less than inside the cell, so low, hypotonic. Make sense? So water will get into the cell. From low to, always water will move from low to high. So from outside to inside the cell. Is it clear? So cell will get what? Bigger. Swelling of the cell, right? Enlargement of the cell. And even may rupture first. Make sense? So in hypotonic solution, water will get into the cell. Cell will get bigger. In hypertonic solution, water will leave the cell will shrink. Now, which solution is good? Not to change the shape of the cell. That is isotonic. Same concentration inside and outside. Make sense? So no movement because already equilibrium is there, right? Same concentration. So when you inject solution into the blood, you will pick the isotonic. Iso means same. Isotonic solution. Right? You will not change the size of the red blood cell. Okay, so just those are the things you need to know. Okay.